Well, hello everyone. Thank you all for joining our webinar today. You've joined our last webinar of the 3-webinar series on navigating the clouds. On our webinar today, we'll give an overview of taming multi-cloud workflows given by Penguin's Director of Cloud Services, Will Cottay. We will wait until the end of the webinar to answer any questions you have for us. With that, Will Cottay will talk to you about how Penguin is exploring multi-cloud architectures.
Well, thank you very much, Ken. And thanks everyone for attending. Just as a recap, the first webinar in this series was given by Matt Jacobs, the Chief Strategic Officer for Penguin. And he talked about what's driving Cloud 2.0, how people are starting to look at computing differently as a continuum rather than just a platform. And the big shift from cloud first to cloud appropriate, and the idea that a lot of people are repatriating and actually putting hardware platforms back on premises again. Last time we talked about multi-cloud and private clouds and hybrid clouds. And then we went through some examples of what some of Penguin's customers are actually doing, mostly using Penguin Computing on Demand and using some multi-cloud some technologies also. Today we're going to talk about some of the platforms, the tools, and the technologies that Penguin has developed, acquired, or partnered with people to enable this. Because this isn't an easy journey to take. So we're actually, Penguin's been doing a lot of work, and we've got a lot of different tools and technologies that make this a lot easier for people to do. Let's first talk about on-premises and private clouds. An on-premise cloud is more than just having hardware that's on premises. People are used to using clouds now. So they expect more flexibility than they get out of just a hardware platform that's sitting there. And that's true with a private cloud, which may be on premises or it may be somewhere else. So for all these, you do need some sort of hardware platform. Now that platform, if you think back to what Matt was talking about, the different ways to obtain that and manage it. So there's a lot of different variety, many different ways you can do that now that give you financial flexibility, can help with managing it, help with design and architecting it. But in general, you'll still have a HPC for most of our customers, or AI-tuned hardware for the platform. Now, to turn that platform into a cloud, you do need some other sorts of technologies. And what we use, and what we've been using on Pod for quite some time, is something we called Skilled Cloud Manager. So Skilled Cloud Manager actually makes that hardware resource look like a cloud resource to the users. So what does that really mean? That gives them more flexibility. They can manage their own accounts. You can actually have multiple managers to manage many different users. So you can have departmental heads have management capabilities for different users in their departments. It allows people to set quotas on usage, to account for the usage, and also gives the possibility to use it remotely or access multiple clusters at one time using that. So that's the technology we use on Pod to turn our HPC clusters into a cloud, really. Underneath that, you're still going to have to provision this somehow. And so let me step back one too. With Skilled Cloud Manager, not only does this provide people with the account management and accounting and that sort of thing, but it also gives people the flexibility to build their own VMs and deploy those on the cluster. And so Clusterware goes underneath that. So Clusterware actually does all the provisioning and monitoring for all the nodes. Now, in a remote cluster, particularly, And that could be on premises with people working at home, the way everyone is doing these days, or to private cloud in a data center. You're always going to have the problem of data gravity. You don't want to have to move that data back and forth. So when you do a large run, you want to be able to analyze that data on the same network using the same storage systems that you've actually done simulations on. So for that, we have a tool called Skilled Cloud Workstation. And I may have mentioned this before, but this is actually a high-powered workstation that can be GPU backed. It's flexible. You can do 4K, you can do multiple screens, and you can then analyze the data right on the cluster fabric. We'll take a quick look at that in a minute here. So this is the what Skilled Cloud Manager looks like to the user. I'd love to give you a full demo of this, but in the short time we have, I can't. So if anyone would like a demo, we'd be happy to do that at any time for anyone. In this case, I'm just looking at the screen, my login screen. It shows me what login nodes I have and what resources I have available. You can see that I can manage users and groups, get usage reports, have usage alerts, and I can also set up quotas and that sort of thing from here. So one of the things that I have here is a Skilled Cloud Workstation. It's a VM, and this one happens to be backed by a GPU. We're going to take a quick look at that to see what that looks like. So I've just clicked on that resource, and it's mine, so I got right to it. And so I could be doing crash analysis and be able to do this remotely. Now, I'll admit this is a video, but I'd be happy to show this to you anytime. This video was actually recorded with me all the way across the country from the cluster that this is running on. And it feels like a very local desktop. This is an ideal solution for some sorts of data gravity issues. And since I did this the other day, I was taking a quick look to see where Hurricane Delta was too, from the runs one of our customers had done on the cluster. You can see it's a very standard workstation environment. Now, both of these products we use on pod, but remember that we also build customer environments with this. Let's talk a little bit about the tools we use to build hybrid clouds. So with a hybrid cloud, we've got the on-premises cloud. And you want to be able to burst out to other resources to maybe because they've got devices or GPUs or something that you don't have. Maybe it's because you don't have the capacity for what you have. Now, in our example last week, or last webinar rather, it was pretty simple. If you remember, it was a weather company, and they had the resources on site to be able to track a couple hurricanes at a time, but sometimes needed to track 3 or 4 hurricanes at a time. So they just use pod as their hybrid. So they would do they would track things on their on-premises ones, and then they'd run their other simulations, their overflow on pod. Well, it was actually pretty easy because the data involved in doing that sort of forecasting is pretty small. And so they didn't have a lot of data to move back and forth. Their resources also were pretty much identical to pod's resources. They have a traditional HPC cluster, and they use a scheduler. So for them to have a hybrid cloud is pretty easy. For a lot of other workflows, it's really not that easy, because you might have a lot of data that sits on your on-premises system that's needed for your runs. you may be using a cloud that's significantly different in architecture than your on-premises system. And so it gets a lot more complex when you're doing that. So there's some technologies that we've developed to make that a little bit easier, or a lot easier in some cases. When you're doing things like large-scale simulation for auto industries, or even for things like yacht design, these are just some of the customers that are using this, or missile design even, there's very large data sets that have to be used. It becomes very difficult to move that back and forth and to keep those in sync across the on-premises and public cloud. So one of the technologies that Penguin supplies is called the Acceleron Managed Data Access Platform. Now with that, there's two different ways, at least two different ways to use that. One is that it maximizes use of bandwidth. So if you're really just moving data back and forth, it really can speed things up about 3 times what you'd see over using just a regular TCP/IP network. In fact, it does that so well that you can use up to 95% of your bandwidth, when typically you'd only get to use about 33% of your bandwidth, maybe 30% of your bandwidth, depending upon what the latency is between the endpoints. That works so well that we were able to demonstrate last year moving a petabyte of data from the West Coast to the East Coast in less than 24 hours. The other way this technology can be used is even a lot more convenient than that. It can give you the global namespace across those 2 platforms. So you can have your on-premises data. You can have a hardware accelerated or just a software-based Acceleron managed data access platform on your on-premise device and be able to see that file system as though it were local from the public cloud or from another cloud. This actually works so well that one of Penguin's customers was able to have their data from seismic data, petabytes of seismic data in South America, where they had no compute. They were now legally able to move all that data out, but they were able to process it remotely. So they actually, from a data center in Houston, accessed that data in South America and did their seismic data processing on that. What's even more amazing, I thought, was that the engineers that did the processing were also in South America. So they used ScoCloud Workstation to access the clusters in Houston. They found that it did not slow down their processing at all. One of the other issues with using a hybrid cloud is, again, it might be architecturally different than your on-premises cloud. And for the weather company, it was really easy. It was exactly the same thing, so they didn't have to worry about different operating systems or different versions of the software or anything like that. Everything could just be installed exactly the way it was on their on-premise. However, that's not true when a lot of times when you're using a public cloud. So what you want to think about then is using containerization. Penguin has long been using containerization in HPC using Singularity. And that's very appropriate for a lot of HPC workloads and other workloads now too. But a lot of people use Docker and associated technologies. And so Penguin has worked with Red Hat to provide a cloud orchestrator with Red Hat OpenShift. Now, most of the customers that are using that currently are in the AI space, but watch Penguin because we are going to be announcing some other, moving into other spaces with that too. We've already helped customers doing that, but again, that's the sort of thing we're going to productize and provide very easily to customers. let's talk a little bit about multi-cloud. Remember from the last webinar, multi-cloud is a little bit different than hybrid, because rather than just moving some of your workload somewhere else, you're actually able to use multiple resources in multiple locations in the same workflow. The example we gave for that last time was the engineering firm that was doing earthquake simulations. And so they would run the simulations on Pod. They'd render the results on Google, and then they distribute the results from AWS. Now, while that works very well for them, it really took them about 2 years to get that down to be a dependable, repeatable workflow. That's really not acceptable for most companies and for companies with multiple workflows. And so Penguin has engaged with a company that actually does workflows. So ParallelWorks is the company that we work with. ParallelWorks is available on Pod. And this is another thing that I would be happy to give you a full demonstration of, and we just don't have time for today. But you can see the sorts of things you can do here. When I want to use Google, I don't have to go out and build a Google cluster or anything like that. I can just say how many resources I need by moving sliders around on this and turning them on and off. The same thing when I'm using Pod, when I'm using the bare metal on Pod. I just say how many resources I want to have access to and then turn them on and off. This is the concept of a workflow store almost, so that someone can write a workflow. There's hundreds and hundreds of these workflows that are already available for well-known softwares. Or you can write one from scratch. It uses the Parcel language, and it's fairly easy to use and fairly easy to learn. So we're going to open a workflow that's similar to the one the engineering company does. This one is a molecular dynamics workflow, but it does the heavy lifting on Pod, and then it goes out to Google to actually do the rendering. So the user's just gone in, they've changed the parameters for this run, they've selected where they want it to run. And then they've actually just started the job. As they're monitoring it, and of course I've skipped ahead a little bit on this because you really don't want to sit here and watch the compute go on. They can look at the results, the intermediate results. They can look at the monitor the different resources. You see we've completed a good deal of work on Pod, and it's now running on Google. And now all the jobs have finished, and we can take a look at what the results are. In this case, you can change the parametric values for the results and visualize them right here. Now this is available on Pod today, and if anyone would like to demo or would actually like to try this, please get a hold of us. I think it's an amazing workflow tool, and it really allows you to select the right resources for the right things that you need. So it was a little bit short today, I'm afraid. I hope that we've got some questions so we can talk a little bit here. Okay, we've got one question here. I understand the tools, but I'm not sure how to make that fit my workflow. Well, that's one of the things that Penguin can help you with. We're very happy to sit down with you and talk to you about what it is you do, what your workflow is. While we do present solutions, as packaged solutions, most of that is really so that it's repeatable for us. We don't expect anyone to use the same solution company to company, really. We expect people to put them together differently. And we're more than happy to sit down and talk to anyone about how they could use these tools in their environment. We've got another question. You mentioned this being Penguin focused. Do I need Penguin hardware to do this? No, not at all. Sometimes it's a lot easier because you're getting the hardware and software from the same people, and so integration is easier. But many of these tools, the Managed Data Access Platform, Skill Cloud Workstation, Skill Cloud Manager, even Skill Clusterware, you can use with your existing hardware or with hardware from other vendors. Got one more. Is the Managed Data Access solution a hardware or software solution? Yes. So it is both. There's a hardware version that's used mainly when you've got a large bandwidth at your disposal. So you can put it, think of it as a data center solution if you're connecting two data centers. It's also available as a software-only solution. So that would be if, let's say you're running some workloads on pod and you want to have access to that data on AWS, you can start a MDAP, virtual machine on pod, and connect that to an instance that started on Amazon. And that's both supported for both of them, and connect those two together. And in the same way, you can access your data either invisibly, or you can use it to move data back and forth. Do we have any other questions? It does not look like it. Well, thank you very much. And I'll turn this back over to Kim then.
Thank you, Will. Thank you for listening to our webinar today. If you have additional questions, please visit our website or contact us for more information.